In section 1.4, we will talk about interval notation. The goals of this lesson are to use interval notation to describe a solution and also to use inequality notation to describe a solution. When we talk about interval notation, we use either brackets or parentheses. Brackets are used when the value is included, and parentheses are used when the value is not included. For these first examples, we're going to start by graphing. So in example number 1, we can see that we have a critical value at 5. We also know that based on the fact that this says greater than, not greater than or equal to, it's going to give us an open circle on the line. From there, we'll go ahead and put the 5 with that, indicating that critical value, and then we want to graph. Now again, if you remember the explanation that as long as the variable is on the left side and it's solved, we can just pay attention to the way that the arrow points. This arrow points to the right, so I'm going to make my graph point to the right. Now the part that's new with this lesson is actually writing this in interval notation. So what we're going to do is decide where the interval starts and where it ends. Now we're always going to read these graphs from the left side to the right side. So the first time that we have a value that works for this would be here at 5. So we're going to start with 5, and then because this ends with an arrow pointing to pointing this way in this direction forever, we know that that's pointing towards positive infinity. So our interval is going to start with 5 and it ends with positive infinity. But then we need to think about what type of, if we're going to use parentheses or brackets. What ends up happening here is that at 5, this value is not actually included in the solution set. It's an open circle, meaning that it cannot be equal to 5, but all values that are bigger than 5 will work. It's going to end with infinity. And what we're going to do is every time we see a positive or negative infinity in any of these solution sets, we will always use a set of parentheses next to those. When we move on to number 2, we'll follow the same process. We're going to start by determining the type of circle. So this one is going to be a closed circle because it's less than or equal to. So it actually would be an included value. From there, we'll list the critical value of 9. Then we look at the direction that this points. It points to the left. And that's what our graph looks like. So now when we go to do interval notation, we start with what is the first value. So again, reading this from left to right, we can see it's pointing with an arrow this way. That is pointing towards negative infinity. So our interval is going to start with negative infinity and it's going to end with 9. Then we need to talk about parentheses or brackets. Well, with negative infinity, automatically that's going to be a set of parentheses. But at 9, because this value is actually included in this set, it will be a bracket. Okay, in example 3, same thing. We're going to start by determining if this is an open or closed circle. This one ends up being a closed circle. We put the critical value of negative 3 there, and it points to the left. From here, when we talk about the solution set, for interval notation, it starts with this arrow. That arrow is pointing towards negative infinity. So our interval starts with negative infinity. It's going to end at negative 3 because no points beyond negative 3 on this side are going to work. So we know it's negative infinity to negative 3. Now at negative infinity, infinity or negative infinity would always have a parenthesis. And then we have to decide if this one's going to get parenthesis or bracket. And again, because it's included, it will be a bracket. For number 4, again, we determine the type of circle. This one ends up being an open circle, and our arrow is going to end up pointing to the right. Again, when we look at the interval, the first time we have a value that works as we move from left to right is here, which is at 1, and that goes on to positive infinity. Again, the infinite symbol is going to get parentheses by it, but our starting value here, because it's open, again, that means it's not included, so that's also going to be a set of parentheses. So that should be our answer. Now we're going to do kind of the opposite. We're given the interval notation, and we want to move that into an equality notation. So again, I'm going to have you start with the graph. Now, negative infinity, when we go to graph that, we know that our arrow is then, that means that the arrow is going to be pointing this way. Whereas in number 2, we can tell that the arrow is going to be pointing to the right. Okay, so let's focus on the critical value here. The critical value in this case is 7. So I need to decide what kind of circle I'm going to have on there. Because it's got a bracket by it, it is going to need a closed circle. Put the critical value there. And then as we discussed before, we can see that because it goes from negative infinity up to 7, we're going to need that on the left side. Now as we go to write the inequality notation of this, we're going to start with x, and then because our critical value is 7, we can put in x and 7 right away, but then because it's going to be all the values smaller than that, that means it's going to be less than, and it is going to get an equal symbol to go along with that because it's a filled in circle. For number 2 then, we start with our critical value of 1. Again, that means we're going to place a circle on our number line. And again, we want to talk about what kind of circle it is. Because this one has parentheses, it's not included, so it's an open circle at 1. Then from there, because it's approaching positive infinity, we'll make our arrow go from 1 to positive infinity. Now when we write our inequality, we start by putting x in 1, and then it is going to point this way. So that's telling us greater than, and then we have to determine if we're using greater than or equal to. This one is not going to have the equal part of it because it is not a filled in circle. And we get to our last 2 examples. So again, for number 3, we start with our critical value of 3. Because it has parentheses by it, it's going to be an open circle at 3. It's going towards positive infinity. That means it's going to the right. So we can go ahead and fill in the arrow going to the right. Then when we go to write our inequality notation, we have to start with x and 3. And because it's all the values that are bigger than 3, it's going to be x is greater than 3. Again, no equal sign because this is an open circle. And then finally for number 4, again, start with the critical value. This time it's filled in, and that's because it is saying that it's equal to. It's all the values smaller than 5, so we shade this way. And then when we go to write the inequality notation, we're going to start with x and 5, and it's all the values smaller than. So it's going to be less than, but then it's also going to be less than or equal to because 5 is an option here. So for homework tonight, you have a few things to do. In Delta Math, there are 3 different assignments, pretty quick assignments loaded there. Those are already in the system for you. And then you also need to complete worksheet 1.4. Worksheet 1.4 will be submitted through Teams, and I will talk about that more in class.